Okay, if you're watching this video but haven't checked the previous part of the episode, you may want to start with that one first and then get back to the second part here. And if you've watched the first part, welcome back. Let's finish this project that is actually close to being done. If you remember, last time we finished with a nice drag and sort for a list of elements, and all we were left with was to scroll the view when we'd move an item beyond the screen boundaries. So this means if I'm holding an item at the bottom, the view should scroll down. The idea we're going to use is one among others, but I found it to be pretty simple. Let me explain the approach. When an item is detected to be currently at the bottom of the screen, we can start animating scroll Y to its maximum value. Because yes, remember that scroll Y is a shared value, so this means you can also use it to change the scroll position. After the animation has started to scroll to the very bottom, you might want to drop this item before the end of the screen. And so what we could do here is to cancel the animation we just started. So to recap, if the item is at the bottom, we start an animation that goes all the way down, and if we happen to take the item somewhere else, the animation should be cancelled. If we look at the code now, this is pretty simple to implement. First, we need to find these two places where we should start scrolling. To find the top one, we can look at when the Y position is lower than the current scroll, minus the scroll height threshold, which just corresponds to how high the scrollable zone should be. In this case, I set it to the height of an item. So here that means we should scroll up. And now if position Y is higher than our screen height minus the same threshold, then we're scrolling down. If this tiny part isn't really clear to you, I invite you to try the code later to really understand how this works. The last case is, if we're in none of these two zones, we will cancel the animation. Cancel animation is a helper that stops any animation running for a shared value only if one is running at that time. Now about the scrolling itself, in the first case we would need to set scroll Y to 0, meaning scroll all the way back up. And for scrolling down, it's a little different. We need to see how far we can scroll down. To get the maximum scroll position, we can compute the full height of what's inside the scroll view, that's our content height, and the height of what's visible in that scroll view, that's our container height. As you can see, I also subtract the top and bottom in sets from the screen height, and that's because our scroll view is wrapped with a safe area view, which keeps the phone notches away and therefore impacts the scroll view size. Just a quick note here before we move on to the next step, this won't work as expected if you're working with really big list of items where a second and a half will be way too fast to scroll in one direction. So in that case, you could compute how much time would be needed based on how many items are currently hidden. So let's say if I have 100 elements below the current one, you could multiply the time it takes for one element by 100 to get the duration. I'm trying to keep this video simple, but just so you know, this should be modified for better scrolling. Great! Now we're missing one last piece here, and it is to make the scroll view scroll to a new value for scroll Y. That's many scroll in one sentence. If you remember earlier, we set scroll Y to the current scroll position, so that's one way we're communicating with the scroll view. But if we're manually changing scroll Y, the scroll view won't update its scrolling. We need this two-way binding that can easily be achieved with Reanimated. 2 steps. First, we create an animated reference and pass it to the scroll view. The only novelty here is that we're now using a regular React reference, and you'll see in a second why. Then second, we need another animated reaction that is called whenever scroll Y is changed and scrolls to that new value. If in React Native you would usually do reference.scrollTo, in Reanimated they just have a function for that also called scrollTo that we'll use in that way. You pass it an animated reference, don't scroll on the horizontal axis, so that's 0, and use scrolling as the vertical position, that's our scroll Y value, And don't animate it yourself since this value is already animated with a spring animation on the other side. Now, because you're still watching, I'm sure you're a curious person, so I will add 2 more tiny bits just for you so you can make this look even better. The first one will be iOS only and makes a whole difference using haptic feedback. When you start moving an item, you can send a small vibration to the user that makes it feel even more natural. Since I'm running this with Expo, I'll be using the Expo Haptics package for that. When we start the gesture, so in the onStart callback, I will run a medium impact feedback, and since this goes on the JavaScript thread, I will wrap it with run on JS. We'll do the same thing when we update the positions, but this time with a light feedback, a very tiny vibration. If you have a chance to give this a try, it really feels like you're moving something in the real world, but on your phone. That's pretty cool. The last idea I have for you is to use a blurry view when an item is being moved. Using a vibrant background gives a nice touch when an item is moving on top of the other song covers. I'll be using another Expo package, Expo Blur, and add a blurred view to movable song. Just wrap the gesture handler with it and change the intensity based on whether the item is currently moving. Also, we need to remove the white background, otherwise we wouldn't see the blurry background view. See? How cool is that? Let me recap briefly what we've done here. We started with a simple list of songs. Each one was wrapped with a movable song component that would contain all the gesture logic. To make it interactive, we've created a gesture handler and attached it to a song using a pan gesture handler that always need an animated view as a child. We then created a system for computing position changes on the UI thread using the positions shared value that would be updated by movable songs. Every time positions would change, the items would also update because we added an animated reaction, listening to their current position, and running a spring animation to move. About the current item that we're moving, we snapped it back to its new position upon the gesture release. Finally, to let our items move the scroll position, we've added 2 zones, one at the top and one at the bottom, to then update and animate scroll Y directly. This was made possible using an animated reference with our scroll view that will allow us to automatically change its scroll position based on any updates for the scroll Y shared value. Okay, I truly hope you found this helpful, and if you did, there's a lot more to come on this channel. Remember to subscribe if you don't want to miss it. Thanks for watching and see you next time.